you will be expected to be able to evaluate first order differential equations on the FE exam. And it should be pretty straightforward, and you're not going to get too deep into what you did in Calculus 2 or 3 at your university, but you still will need to remember how to do this on test day. And so in this video, I will work through how we can determine the solution to the differential equation dy dt plus 5y equals 0 with the initial condition that y evaluated at t equals 0 is equivalent to minus 2. And so the very first thing to note here is that we have a differential equation that is separable. And so what separable refers to is the fact that we can completely isolate our two variables on either sides of this equation. And so what I mean by that is if we subtract 5y here, we can turn our solution, or this equation, into dy dt is equal to minus 5y. And now if we multiply both sides by dt, we can see that and then dividing by minus 5y, we end up with minus 1/5 times 1 over y times dy is equal to dt. We now have y on one side and t on the other side of this equation. If we now integrate both sides of this equation, we can get one step closer to our final solution. And our ultimate goal here is to get y as a function of t for our given differential equation. And so what we see here is that because minus 1/5 is a constant, we can pull this out. And because we have no limits on our integration, we're going to need to remember the constant of integration in this calculation. And so what we're going to have here, remembering what the rule is for the integration of y to the minus 1 power, or 1 over y, this left-hand side is equivalent to minus 1/5 times natural log of y. And there is a constant here, but you can lump it into the constant on the right side of the equation. This is equal to integral of essentially 1 times dt, which is equal to t and then plus some constant c. Remember to include the constant of integration when you are doing this stuff. It is very easy to forget. Now that we have it like this, we have to remember our ultimate goal here, which is to get y as a function of t. And so moving forward, if we multiply this whole thing by quantity minus 5, we arrive at natural log of y is equal to minus 5 times t, and then I'll call this new constant plus c1 because I'm lumping in the minus 5 into this new constant. We now want to still isolate y, so we're going to take the exponential of both sides of our equation. And an important rule here is that if we have the exponent of minus 5t plus c1, this is really equal to a multiple, which I'll call c2, times the exponent of minus 5t. And this is equal to y as a function of t. Okay, and so we're almost there, but we need to remember that we were given our initial conditions early on in our problem statement. And so what we'll do next is actually plug in these values. So we were told that y evaluated at t equals 0 is equal to minus 2. So therefore minus 2 is equal to c2 times the exponent of 0. And this term here is really just equal to 1. And therefore minus 2 is equal to c2. And so what this tells us is that y of t is equal to c2, which we just evaluated was minus 2, times exponent minus 5 times t. And so this is the final solution to your differential equation, which is sometimes referred to as an initial value problem, an IVP. and I hope you guys find this useful, and thanks for watching.